Good afternoon, and thank you for taking the time this afternoon to attend my session on Agile Mastering and new way of thinking about MDM. I normally like to start these things off with some kind of a little joke to break the ice. This time I'm going to go a little contextual, and it might not work. So 3 guys walk into a MarkLogic Agile Mastering data hub, and only 1 guy walks out. Merged, haha. Okay, so my name's Mike Doan. I'm a solution director here at MarkLogic, responsible for coming up with solutions built on MarkLogic that help you to solve some of the problems better with MarkLogic. And I've been here for about 9 years. I have been working for companies that are involved with data integration for about 20 years. By the end of this talk, it should be clear to you, if it's not already clear to you, that when you bring together data and you're trying to create a common view, as is important in master data management, busting data silos play a critical role in that. We are seeing master data management opportunities in pretty much every customer that is integrating data. Since we're the world's experts at integrating data in silos, that just happens to be just about every customer, whether it's healthcare or insurance or media or any of the government agencies, whether they be state in another country. You pull together a lot of data, you're going to have a lot of different copies of the data, and you're going to have to master it. And we are providing a way to do that differently. So there's many different definitions of master data management. It's a complex domain that's practiced in a lot of different ways. There are, I've listed 3 definitions up here. There's plenty more that I could have listed. And there are no 1 or 2 sentences alone that would accurately define what master data management is. It's too many different things to too many different people. Coming up with a strategy for it is very personal. It's not unlike coming up with, buying a car. Even in my own family, the criteria we use for buying cars is quite a bit different. My wife's interested in having 7 seats, 3 rows of seats, leather, and I'm interested in a powerful engine that goes fast. So MDM is no different. Everybody has a different set of requirements. So before you embark out on an MDM project, I advise you to think long and hard about what your business goals and objectives are for that project. So why is MDM needed? It's needed to get a common view of your data across all the different instances of data in your different silos. So in order to better understand or get some context around that, let's take a quick look at some examples of how it's used. In healthcare, it's used for master patient indexes to identify all the different instances of a specific patient across the different systems that are part of a healthcare enterprise or organization, despite the fact that each of those systems might have a different patient ID for those for each patient, and they might have some slightly different spellings. They might have an old address and a new address in another one, and you want to consolidate all that so you have a better understanding of who you're dealing with, a more consistent view of them. In any consumer product company, they want to create a customer 360. So they know all the different products that you've bought from them. They want to know every touch point that we've had with them, how we've marketed to the customer, if they've called into the call center before, what the problems were, if they filled out a survey. You want to be able to know all that when somebody calls in again and a customer service representative is dealing with them. They're able to help them a little bit better. Marketing's able to target their marketing to them in a more streamlined manner and with higher success rates. And in banking, it helps to know what products our customers, their customers already own. So how many of you people own credit cards and you receive credit card offers in the mail for that very same credit card on a regular basis? So, good. I have 2 Capital One credit cards, and yet every week they send me an offer. Very expensive, nice mailing. If they had a better mastering, if they better knew who I was, then they could avoid some of that. They could spend a little less money and maybe send me some stuff that I don't already have. So proper data management is all about getting a better view of your customer or of whatever is important to you. We see an awful lot of person 360s and person mastering, but the same thing applies if it's asset inventory, if it's a product that has a lot of different names like pharmaceutical drugs, or I'm sure there's a host of things out in your respective businesses that you're interested in mastering. They all kind of involve the same thing, finding duplicates and treating them with some consistency. So it seems pretty straightforward. Master data management is a good idea, something that you should be doing. Yet it's not that easy to do using the traditional way of performing master data management with relational databases. And let's take a look at why that is. So first off, we have, there's a lot of hurdles that traditional MDM has to surmount. Faces a lot of headwinds. Not the least of which is you have a lot of very highly structured data sources that you're trying to bring together, put into a common model, and to do so, you have a lot of upfront modeling. You have a whole lot of ETL scripts that you have to write, and that takes a long time. It's very slow to show progress. And while you're busy doing that, and while the business is not waiting for you, it continues to change. The business goals might change. The data sources change. New ones might be added. And the relational technology has a tough time keeping up with those changes. Couple that with the fact that traditional MDM is usually performed in a back office by an IT staff that's a little bit disconnected from the business. And you have slower reaction time. And when you do have a reaction, sometimes that reaction is to fix it in a way that doesn't necessarily align with the business goals. Now, there are some successes out there. There's some excellent practitioners of MDM. They've learned to navigate the waters. They know how to anticipate changes that are coming and to actually handle those. And they do deliver successful projects. Never fast and never cheap. Now, there's also some successes in custom solutions where a portion of the organization has to support something like a marketing campaign. So they set out, they start their project. They have a lot of ability to make some changes to the mastered model. So they're a little bit more nimble than would be normal. So they're not constrained by the fact that they have hundreds of data sources to deal with. And as a result, they can successfully deliver. But what they're delivering is not really enterprise-wide. It only serves a smaller set of interests. And it's that smaller set of interests that makes them successful. The fact that they're not constrained by a rigid model and that they are not chasing a perfect model up front gives them a little bit more flexibility versus the typical way where you're trying to achieve something called a truth-based model. And the truth-based model is based on a very rigid definition of the entities and their attributes. And you have to get unanimous agreement from all the different actors that are part of, that own these different systems. And you got to do it up front. It's already difficult to get unanimous agreement. But if you have to do all this stuff up front, it's virtually impossible. So a better approach than this truth-based method is something that we're calling a trust-based model. And that's where you keep all the data and you master a subset of the data. You keep all the data that was associated with the changes. You heard some of the stuff I'm talking about today. You kind of heard this morning when Gary was talking and when David Gorbett was talking. You want to hold on to the metadata. You want to hold on to the source data. You want to hold on to all of that so that your users know how you arrived, how data became to look like a certain way, how master data came to look like a certain way, and they're able to make decisions for themselves on how it should be used. And when I say users, it's in a broad sense. It includes developers as well. So let's take a look at a traditional life cycle for MDM. It's got a lot of steps. And if you know anything about any of these steps, you know it's going to take a long time. First off, you have a lot of different data sources, and you want to analyze those data sources and understand all the different entities that are in them. And you want to understand the data a little bit better, so you create these data dictionaries. And then once you have all of those, you need to begin to assemble those into a master list, and you're looking for the common entities and the common attributes. And you use these to create your canonical, your perfect model. Once you have that perfect model, you've got to decide, how do I get data from the source systems into that canonical model? So you have to write these ETL scripts. How often am I going to have to do it? What am I going to lose when I'm doing so? Things like that. And this is before you've even begun to load data into that source system. You still have to load the data, to test it, to do things like data disambiguation, data governance activities, more testing. And then you're finally at the point where you can begin to do mastering. But it's taken a really long time to get here. And during this period of time, your organization has moved on. Your champion or champions may have changed roles within the company. They may have even left the company, or they simply got bored waiting for you to get around to actually showing them the benefits of this master data management project. So the amount of time that is spent because of that rigid structure, the rigid technology, makes it a lot harder to succeed. So let's delve into why, a little bit more about the relational approach that's difficult. I said we've got a lot of different data sources that we want to conform into a single model. That alone is pretty difficult. This is a generic, kind of makes it a little bit easier to see, but we're really talking about some of the same stuff. You've got a waterfall approach, a sequential approach to the different activities. Each of the activities takes quite a bit of time. You really have to have a very good understanding and be very accurate in your understanding of the different steps. And it's not easy to accommodate changes. So IT staff can't easily react when a data source changes or something along those lines. And inevitably, there is going to be some change along the way. And when it does, things change, and you're left with this again. And do we really have to repeat this again? The reality is, if enough things changed, or if anything changed, especially if you got a new data source or you got changes to the existing data sources, you're going to have to repeat these steps. It might be a little faster than the last time, but you are probably going to have all these steps get impacted, and it probably won't be the first time you do it, so you're going to have to repeat it again. The whole process is slow, it's brittle, it's expensive, and there's got to be a better way. Keep going to that. So if you're still unsure why this is so hard, let's take a little look at one of these schemas. So this is not a particularly complicated schema. Starts to look a little more daunting if you want to combine these schemas into one as you start adding some more to the screen. And as you add more, oh, that didn't get picked up. As you add more, and now we only have 7. We don't have the 100 that we were talking about today, and they're not, again, all that complicated. Every one of these tables is a little bit different. The entities they represent are split up in different ways. They have different column names, and even within those columns, you can have data that is basically supposed to represent the same thing, but it's stored differently. So you've got trues and falses, and T's and F's, and zeros and ones, and male and female, and M and F, and those are easy. Where it gets a little bit difficult is when there's kind of a semantic mismatch between the data, and you have an inventory system that is storing a product count, and in one system, it's actually storing the number of boxes that you have available in stock, and in the other one, it's storing the actual number of products. You might have 100 products in every box, and so you've got this mismatch, and you've got to handle that sort of thing when you want to move all this data into a common model. So all this complexity, and we want to conform it to a common model. It's a rather daunting task. It's the reason for all those steps that we just looked at. And it's the reason why so many of these projects end up failing. So since so few of these projects work, there's got to be a better way, a more modern approach using a more modern architecture where you stop boiling the ocean, you get started faster by loading data as is, you show incremental progress, and you show it a lot faster than you would before. And when you show progress faster, you keep your customers and your champions happy and engaged. Why not align with the business goals as well? If you have MDM, which is designed to solve business problems, it should be aligned with those business problems. So find a way to more closely align your MDM strategy with your business problems, and make it business outcome driven. It would also be nice if you could be a little more flexible and you could actually respond to some of these changes. Believe it or not, it's actually possible to accommodate all of these headwinds. So this is possible by fixing the architecture. And at MarkLogic, we have an architecture called an operational data hub. And an operational data hub is a pattern where you physically move the data from the source systems into MarkLogic. We re-index it, index the heck out of it using the Ask Anything universal index. And a data hub is different from a data lake. So it's different in a number of different ways. A data lake, you put all the data in. It's not necessarily indexed. But in a data hub, you have a highly indexed data source that's capable of allowing you to do rich ad hoc queries, supporting analytics, supporting real-time access to the data, two-way access flows between the data sources and the hub, even the ability to have a application use the data as a source system or even as a system of record because it's transactional in nature. Because it's real time, that allows you to run your business on it. So it's kind of unheard of that you would be doing master data management in an operational data hub, but it's one of the great enablers of Agile Mastering. So Gartner recently stated that real-time mastering is critical to success of metadata management projects, especially given the pace of change of data today. So we have the new approach to master data management, Agile Mastering. And our Agile Mastering solution is not exactly a product per se. It's more like a suite of functionality that gets deployed inside of an operational data hub. And because of that, you get a lot of different benefits. You get a 360-degree view of your entities. You get the ability to have an application work directly in the data hub, so that things like duplicates don't get inserted. You can operate in real time. It supports things like semantics, so that you can support more than one domain. It's also able to allow you to go from collecting data to connecting it, which allows you to have rich relationships among the entities and to support a wider range of use cases. So you get everything that all the benefits of a data lake and much, much more. So there's a lot of different ways that the operational data hub can help customers. That bank that we talked about earlier is going to know that they were selling me that I already had a couple credit cards, and it can streamline operations, save some money, and maybe send me some offers that I might actually bite off on. An airline is going to have the ability to know that you were just trying to buy airline tickets when you call into the customer service rep, and they're able to pull you up from your phone number, and the customer service rep knows exactly what you're doing, is able to help you solve that problem quickly, and you leave with this kind of feeling of, wow, they really know what they're doing. A car manufacturer can know all the different pieces of data that you downloaded from a website. When you do a test drive, you have to give them your driver's license, so there's another system that captures your information. They put all of this stuff together, and they can send you offers that you're actually interested in.
Could you explain a little bit about the bi-directional nature of this? Give an example, a call center where someone calls in to change his or her address, and the CSR after hanging up the phone has to log into 5 or 6 different systems to change that address.
I actually have that's one of the use cases that we do end up talking about.
I'm thinking about it from the entitlement perspective on those.
Entitlement?
On those 6 or 7 systems behind the scenes, and how much work that is to make that bi-directional.
So you'd have to spend a fair amount of time trying to figure out if all of that information has to get propagated to those systems' own systems of record. It's a little easier if you decide to have those systems use the operational data hub as the system of record, because it's fully transactional, and when you do that, you get this extra access to a lot more information that you might not have thought possible, but you can do a little bit more with it, right? Okay, so it helps a lot of different industries get a better, clearer understanding of their customers without having multiple copies of them. And as a result, you get better customer satisfaction, better customer experience, and you do it more efficiently, and you do it with less cost. So let's get into a little bit about the features that allow you to do Agile Mastering. And a lot of these are unique to MarkLogic, but not all of them. But the combination of them is indeed unique to MarkLogic. So first off, we have Schema Agnostic. Wouldn't it be wonderful if we didn't have to do all this upfront data modeling, and we didn't have to write all these ETL scripts in order to get our data into a place where we could begin to do some of that mastering? Well, with Schema Agnostic databases, you can. You can load data as is, and you can begin to query it immediately. It allows you to get ahead of the problem, and there's a reason why I'm listing it first. It's absolutely critical to successful Agile Mastering. If you load it as is, you progressively master it, and you begin to deliver incremental results quickly. And what this does is it allows you to also handle the changes that are going to happen. So all those different data sources that are tied to you, it's kind of inevitable that some of them are not going to change, and it's inevitable that I said that back, 2 double negatives. It's also there's strongly likely that there's going to be some new data sources that get added, and Schema Agnostic allows you to accommodate those. It really does allow IT to keep their master data management project in sync with the business goals and the business changes, something that has pretty much eluded MDM up until this point. We talked about this a little bit. Contextual mastering. Wouldn't it be great if you never actually had some of the duplicate data find its way into the database in the first place? Since MDM is all about mastering the duplicates and merging them and having one consistent view, if you could avoid that, you'd be saving yourself a lot of downstream activities. And you can do this with contextual mastering. That's basically doing your mastering in the context of the business activities themselves. For example, a call center worker gets called by a customer, and the customer's been trying to create an account or fill out an online application, and they ran into some kind of trouble. And while they're on the phone with the customer service rep, the rep is immediately able to discover that they already created an account, or there's 2 applications in here that the guy had started filling out, and to actually take action to merge them or to abandon one of the applications and begin creating the second one. So what you end up with is you never create the problems that you have to clean up in the first place. And so you don't have to do any of that back office work to do that cleanup. Contextual mastering saves you time. And in order to do it, you have to have an operational system to do it in. Okay, so all the data. Traditional MDM doesn't master all that much of the data. There are too many different systems to support to find a model that's going to be usable by all of them. And the thinking goes, largely technologically limited, that you should really only be mastering a small number of attributes for any given entity. But the reality is, these MDM systems are supporting a very wide range of applications and systems out there. So the likelihood of only a small set of attributes serving the needs of everybody is pretty darn low. Wouldn't it be nice if you could keep all the data, keep all the metadata that was associated with any changes to mastering it, master a subset of that data, and furthermore, to allow all of it to be queried at the same time. And you can do that with a schema agnostic database. So with Agile Mastering, you've got multiple sources of data. We merge them into a single copy of a file. Sometimes we have a second related copy that stores the metadata, but there's no reason why it can't be one copy or two. It depends on the toolkit that we're creating has the ability for you to choose between that. So by keeping all the data, you're able to go back and fix mistakes. You can unmerge data that wasn't supposed to be merged in the first place. And it allows you to take that, to achieve that trust-based model that we talked about earlier. Unlimited metadata. I don't know. All the data, unlimited metadata, they're closely tied together. So data governance, compliance, data stewardship in general, and a whole lot of business use cases all benefit from storing as much metadata as possible about anything that you change, especially about your mastered data, because of all those reasons that were cited earlier today. There's a host of different regulatory compliance, governance needs, maybe backing out, allowing users to trust what the data is. In law enforcement, they want to know who or how did we get a certain piece of information, where did it come from about a suspect or about an unsolved case. A doctor wants to know how a diagnosis was arrived at. Who made that diagnosis? When did they make it? Under what sort of circumstances? And what tests did they use to arrive at that diagnosis? They both probably want to know a history of the changes to the people that they're helping or chasing. And they both want to know who accessed any of that data, who made any changes to it, and who had the right to make any of those changes. And all of that is stored as metadata. So in Agile Mastering, you keep it all. For every data element, you can query it all. It's treated just the same way as the regular data. It even appears alongside the regular data. And that's very powerful. That, combined with semantics, makes for a very powerful model. Now, in ETL, you have a lot of data getting left behind. You have data lineage getting lost. You're transforming the data and making changes to it so that it can conform to the rigid columns of the destination database. And you lose you lose, sorry, I lost my train of thought. You might lose the lineage, the timestamps. You don't know how we arrived at this, what transform was used. And when you lose all of that data, are you able to fix problems that crop up? No, you probably can't. But if you're storing unlimited metadata in the database, you can. It is possible. Simplified architecture. Keep KISS principle. Don't underestimate the power of the KISS principle. Let's say you have a simplified architecture that includes a combination of search and query that's able to search and query across a wide range of different data types, including geospatial, XML, JSON, semantic data. And that's going to allow you to create much more complex algorithms that make it easier to find the matches in your data without necessarily having to do as much changing to the data. You can accommodate a little bit more when you're able to have this super rich search that is supported out of the box using the Ask Anything universal index. Traditional MDM architectures require a number of different products. So they've got relational databases, they have ETL tools, they have search engines built in, sometimes they have content processing frameworks, data virtualization technologies. So not only does having all these different things make it difficult to manage, it also makes data integration tasks a lot more difficult. It makes it more brittle and expensive to make any changes. And things fall through the cracks. You don't necessarily know what happened to the data as it was going through all those different products, because not all of those pieces of information are propagated into the master data management database. So this is kind of important because MDM and data governance go hand in hand. So if you're losing data, you're kind of not achieving your goal. So Agile Mastering takes place in an operational data hub. And this is a single unified product where you've got a database and search, application servers, application services, all built together, all QA'd in one single platform that can keep track of everything that happens within it. So you get complete auditing. You don't lose sight of what happened to any piece of data, and you can hold on to it. And you can, and when you add it to your documents, to your entities, you can be sure that you're going to be able to search across it. So, logical data model. Why not store your data in a way that makes sense to everybody, and that can also be indexed in a way that allows it to be queried in any way that you hadn't necessarily even thought of first? No limitations to what it can store. Instead of, that obviates the need for a lot of complicated tables to break apart the data and stick it into. You can use documents, and entities are naturally modeled as documents. And not all of them, but the vast majority of things do get modeled as documents. And documents are often the way that we deal with things in the business. So if you're performing business functions, you're doing some sort of workflow, you're often going to be interacting with a document in that process. Not only that, document-oriented databases are schema agnostic, which means they can easily accommodate changes. You can keep adjusting the document, and that makes it that much easier to master. So you don't have to split up the data. You get to store it all together. And so let's take an example. Let's take this as an example. You've got a patient information form. We've all filled them out before. You can see why some of the data might get shredded up and put into different places in a relational database. But you can also see that this is all my health information. So it really does make sense to kind of store it in the same place. And the reality is, it can be stored in the same place. You can store it in a continuity of care document or any other, and this can even be modified so you get to insert a little bit more metadata, the original source of all the information. It's possible to model extremely complex hierarchical things in XML and JSON. And if you throw in the ability to store semantic data about things, to store relationships, you can have the best of both worlds. You've got a denormalized document-oriented database with a little bit of normalization to kind of tie together a few of the things. Semantics are great for storing relationships, for storing simple facts about things, and relational databases also have relationships between them, but those kind of relationships don't really have any meaning except to IT folks. You're only storing the cardinality of the information. Doesn't mean anything to the end users. With semantics, there's no limit to the kind of relationships, the number of relationships you can have between two entities. So here we have some beneficiaries. They have benefits, and a beneficiary can apply for benefits. They can be denied benefits. They can call to complain about benefits. They can be found to have fraudulently obtained benefits, and many more. There's really no limit to the number of things that you can, number of ways that you can interrelate. And this supports something called multi-domain mastering, which allows your master data management solution to provide value to a much greater range of users and applications. And it enables a hybrid approach to master data management, because you can actually leave some of your data in the source systems and then use semantics to relate it out to it. And it improves matching. So if we look here, we've got two spellings of Jonathan Jacobs. He's related to the same two, but they're both related to the same two people through the same kind of relationship. So when you have data like this, you're virtually guaranteed that you've got a match. It's one more way that you can improve your data matching, and master data management is all about finding the matches and so that you can merge them and clean up your data. Secure your data. If you're going to improve, if you're going to bring all your enterprise's data assets together, you better make sure that it's going to be secure for that reason alone. And if you're going to allow your applications to interact with that data, you better make sure that you have robust data access controls to meet all your data governance requirements. MarkLogic security is fantastic. I can't say enough good things about it. It was already the #1 NoSQL, already had the best security of any NoSQL product out there. First one and only one to be Common Criteria certified, and it's only gotten better. MarkLogic 9 is out. You've got element level security, redaction, database encryption, external key management. All these things are key to an operational system, and you need an operational system if you're going to be performing Agile Mastering. Okay, lastly and closely related to security is auditing. You want to be able to audit everything. Whenever you want to be able to answer the questions of when, what, why, how something was changed, and you want to be able to do it for every single piece of data. Even if that was performed, even if the change was performed by an automated system, or if it was performed by someone who's trying to cover their actions. We talked a little bit earlier about traditional MDM having a lot of different products. Well, makes it very difficult to audit actions when you don't even know that the actions happened. MarkLogic, one consolidated platform, capture everything in that platform, full auditing. It supports a wide range of use cases, and full auditing is a requirement of Agile Mastering, and unlimited metadata is a requirement of being able to store all that audited information and still be able to query it. So that covers all the features. So let's jump real quick into the real world examples. Time check, I've got a few minutes. Okay, great, thank you. MarkLogic, if you didn't know, is the database behind the Data Services Hub and the Health Insurance Marketplace database for CMS, the Center for Medicare and Medicaid Services. The Data Services Hub is what validates the information in a person's insurance application, and the other places where all the insurance applications go. All the different Medicaid transfers find their way in there. Insurance policies go in there, and all of this is served up to end users in very high volumes. Data finds its way into healthcare.gov in a number of different ways. A single person can abandon their application a number of times, come back in, there's multiple copies of their application lying around. One of their family members, unbeknownst to them, may have gone in and filled out an insurance application. So you've got two people that filled out similar applications. They appear on separate applications. You've got Medicaid transfers happening from the state source Medicaid systems, and that stuff getting propagated into healthcare.gov. And as a result, people appear in many different places, in many different forms, on many different applications. And CMS needs a way to relate all of that, tie it all together, and support things like monitor for double dipping, do analytics on how many people are signing up without double counting for people, and to just basically generally understand the marketplace consumer. So in order to do that, they perform operational mastering. There's a bunch of people that are using this system at any time, up to 300,000 at peak. And whenever some Medicaid application comes in real time, the system automatically finds the matches. It's always kind of looking for matches and doing these merges because people are continuously inserting new applications that are basically duplicates So in order to do this, we use fuzzy matching and field-weighted algorithms combined with things like name synonym thesauruses to broaden the search and to find all the potential matches that are out there. And then we have data merging capabilities that are executed in a combination of automated manner, and when you don't have a high enough match score, they go into a queue to be handled by a person who decides whether or not something's going to get merged. There's also cases where you have a customer service representative doing the same thing as we talked about earlier, which is they're dealing with someone who had a little bit of trouble with their application or who wanted somebody else to do there's a lot of people who actually call in and they just want somebody else to do their application. But the customer service representative needs to be presented with all the possibilities of who this person is as they're typing stuff in. It's constantly getting updated on the information that's there. And they get presented with duplicate applications, duplicate records of people, and they're able to make decisions on how those things should get merged in real time, avoiding some of that cleanup down the road. They call it operational mastering, and here I'm calling it contextual mastering. Oh, yes. One more thing. Mistakes do happen, and CMS has kept all of the original data so that they can back out of those so they can fix those mistakes. Some of these things are the hallmarks of Agile Mastering. Next up, we have the Minnesota Criminal History System. And they have data on criminals coming in from a wide variety of sources across the state. They come in from the courts. They come in from police stations, come in from various counties and other agencies across the state. And they come in a lot of formats, whether it's court appearance documents, police bookings, releases, just a host of different documents that all contain information about the criminals or suspects. And they need to be able to find all the matches and merge them. And they call that colligating. And they do that the same way as CMS does with these field-weighted fuzzy matching algorithms and some data merging, combination of automated and manual methods. Oh, it never did switch. Sorry. It's not going to. Okay. Doesn't look a whole lot different, but counties, police departments, juvenile services, live scan, court appearance, lots of different data types. They got to merge it all together, and they use MarkLogic to do that. It's kind of a textbook case for Operational Data Hub / Agile Mastering, if there were a textbook on Agile Mastering. They needed the ability to ingest data as is and to store everything, to store the original source as is, to keep the data lineage, to keep timestamps, to keep source counts on each piece of data element. And they needed to be able to query it all across all the different types of data. So they relied on the Ask Anything universal index to do so. They needed to be able to be notified about certain records whenever they change. So they use MarkLogic alerting for that. They store the data and they get alerted, proactively notified whenever something has changed. And they needed to be able, they needed government grade security. They had a unique feature aside from just protecting PII. they had a unique feature where they need to be able to contextually elevate somebody's security permissions. When you're performing a background check, you need access to more data sources. So they have a way to temporarily elevate the person's security permissions so they can do what they need to, and then it goes back down to the regular level. And lastly, they found it was just too difficult, too complicated to store all their entities in a relational database and still be able to perform search, update, merge, unmerge with good performance. So they opted for the storing each entity in a document. Seemed a little more natural to them, and it was a lot easier to do the search, update, merge, and unmerge actions. I'm just going to, no, it stopped working. OK, so quickly go through this. This is the Minnesota application. You're looking at one of the bookings, and you got some options. You pick compare. You go to a screen where you're looking at two people side by side. This is a manual compare. Most of these things have some differences, but they're fairly close. The IDs match up, so this guy's probably going to decide to do a merge. I wanted to be able to show this as a live demo, but they wouldn't let us, unfortunately. OK, so just to summarize what we talked about today, MarkLogic provides an alternative to the traditional way of doing MDM. And the way that we do it is, what makes it better is we're operational and transactional, enterprise grade, makes it easy to get data in. You are able to handle structured and unstructured data and metadata at the same time. You're able to quickly respond to changes which are going to inevitably occur. And when you do have all that data that's in the system, it's easy to query it. And it's real time, so you can support two-way applications. And it's enterprise grade. So you have this ACID compliant database that's kind of normal for relational, but it's a game changer for NoSQL. And it's absolutely required if you're going to run something operational. And we have already established that it also has to be flexible, so you pretty much need an operational NoSQL database. And you want great security to protect the data. We've talked at length about about MarkLogic's capabilities. OK, last slide. So we've covered everything that's needed for Agile Mastering, and MarkLogic provides all of these features that are here. It provides them out of the box, without caveats, without apologies. So with this, it's time to start thinking about thinking about MDM in a new way, taking a new approach to it. And you can with MarkLogic. So thank you for your time. That's all I have.
We have time for one question.
Time for one question.
Yes, if anyone has a question. There we go.
I have two questions. Or too bad. You can merge them if you want. What is the as-is format?
Yes.
What is the as-is format for relational data?
Excuse me?
What is the as-is format for relational data?
OK, so there's a number of different ways that relational comes out. It can be exported, each table as CSV, and with a header that tells you what the column names are. And when we deal with that, we automatically create XML or JSON on loading that uses those column names as the XML tags. But there's also a way to do some normalization during export. So you can write some SQL that actually exports the data as XML or JSON in a somewhat denormalized way, and we can load that directly into MarkLogic.
The second part of the question is, what about the schema infrastructure embedded in that relational database? Because if you take the data and don't take the supporting schematics with it, you've lost the crucial part of the data. So what happens to that?
So I think we're going to need to talk about that one a little bit more. But what you do get is once you load the data as is, and you can immediately, because it gets all indexed and stuff, you can begin to search it and better understand what you have in different elements. Well, if you left behind the business rules, then there are steps that you have to take to integrate those into the hub. So no, there's not necessarily magic involved there.
All right. Thanks, Mike.
Thank
That's
you,
all the
Lisa.
time we have.